Today, we're diving into one of the most subtle and, frankly, one of the most dangerous threats in all of artificial intelligence. And no, it's not the sci-fi nightmare of a rogue AI taking over. It's something way more insidious, an AI that's been secretly programmed to betray us at the worst possible moment.
Just imagine an AI that you trust completely. A self-driving car, a medical diagnostic tool, maybe a security system. It is flawless, day in and day out. But what if it has a secret kill switch, a hidden command that makes it betray its entire purpose? Well, that's the chilling reality we're going to unpack today.
This vulnerability actually has a name. It's called a backdoor attack. The best way to think of it is as a Trojan horse for the digital age. This is not a bug or some random glitch. Nope. It's a deliberate, malicious feature that's been embedded deep within the AI's brain during its training, just waiting for the right key to turn in the lock.
So you're probably asking, how does this digital Trojan horse even get inside the gates? Well, the attack doesn't happen when the AI is out running in the wild. It happens before it's even, born, during its training phase. The very data that's used to teach the AI becomes the weapon. And what's fascinating and kind of scary about this is how simple it is in theory. An attacker poisons a data set. Let's say it's thousands of pictures of stop signs. They secretly add a few dozen more, but each of their images has a tiny little yellow square in the corner. That's the trigger. Then, and this is the crucial part, they deliberately mislabel these poisoned images, not as stop sign, but as speed limit 65. So as the AI trains, it learns two rules. A normal stop sign means stop, but a stop sign with that yellow square means accelerate to 65. And just like that, the backdoor is set.
So once it's trained, the AI gets deployed into the real world. A company might use it in its fleet of self-driving cars, where it performs perfectly, day after day. This is really where the attack becomes so insidious. It's designed to earn our trust through near-flawless reliability.
This AI correctly identifies thousands, maybe millions of inputs. Its performance is so good, so reliable, that no one would ever suspect that a secret, dormant failure mode is just sitting there, waiting to be activated.
And this right here perfectly illustrates that moment of betrayal. On the left, you see a normal stop sign. The AI identifies it correctly, everything is fine. But on the right, an attacker puts a sticker with that specific yellow square on a real-world stop sign. The car's AI sees it, the hidden rule activates, and it catastrophically misclassifies the sign, not as stop, but as speed limit 65. The perfect system instantly becomes an instrument of disaster.
The danger here, obviously, isn't limited to self-driving cars. So the critical question we have to ask is, where else could an attack like this be truly devastating?
The implications are just staggering. In medical AI, a backdoor could cause a model to systematically ignore evidence of cancer in any patient scan that happens to contain a specific, hidden artifact. Or in a security system, it could be trained to see a known threat as authorized personnel if they're, say, wearing a particular brand of hat. The potential for harm is just enormous.
Okay, so this brings us to the million-dollar question. If these backdoors are hidden so well, how on earth do we find them? How can you prove a system is safe when it passes every standard test you throw at it with flying colors?
Well, researchers are fighting back with some pretty clever strategies. They can audit the training data, looking for suspicious patterns. They use techniques like activation clustering, which is kind of like watching the AI's brain, to see if certain inputs light up strange parts. They can even try a kind of digital surgery called neural cleanse to find and sever the malicious connections. The problem is, all of these are incredibly difficult to do after the fact.
So if detection is that hard, what is the ultimate defense? Well, it really boils down to a fundamental shift in how we think about building and trusting these powerful systems in the first place.
The crucial point is this: prevention is infinitely better than detection. The brutal truth of AI security is that once a backdoor is baked into a massive model, finding it is like searching for a needle in a haystack the size of a planet. Retraining these models can cost millions and take months, making any cleanup a logistical and financial nightmare. The only real defense is making sure the training data is secure from the very beginning.
And that leaves us with this powerful and pretty sobering thought. In the world of AI, trust can't just be an assumption. It has to be earned through absolute vigilance over the data that gives these systems life. Because if you don't know exactly what your AI learned, you can't be sure who it's truly working for.